Wanted to come back to trophic hormones for a minute and review a few things that we might have touched on during our last lab together and finish up a few things before we move forward into muscle. In this coming week for sure, I want everyone to be on muscle, but just wanted to wrap up a few things with our hormone chapter 6, which overlaps with chapter 21, just a few selected pages in chapter 21, just to make sure you guys are moving forward. The human body is going to use over 600 different hormones to help manage physiology, and we're just reviewing, a few highlights, really. And I know this chapter may seem like a lot of chemistry or kind of confusing, especially as we focus on structure and function. But the trophic hormones we learned are regulatory, and they influence the size of their target glands and also help stimulate the release of chemical hormone products. So hormones that control other hormones. By definition, that's what a trophic hormone is. Let me go ahead and click through to the next diagram here, if I can get this to work. Here we go. The anterior pituitary. Okay, so we first looked at the hypothalamus pituitary connection in Unit 2. And in this diagram, we're going to the anterior pituitary, which is true glandular tissue, as opposed to posterior pituitary, which was neural tissue. We used axons and action potentials to stimulate hormone release, two key hormones that we'll come back to. But in this case, the anterior portion of the pituitary gland is secreting 6 important trophic hormones, and you can see the arrows diagrammed out towards their target tissues, these other glands. So hormones that beget other hormones. So let's go through the 6 key hormones and their function, starting with TSH over here on the right at the top. TSH is thyroid stimulating hormone, and it's targeting the thyroid. So we see that butterfly-shaped gland. It's found in our neck. It's pretty superficial, and you could probably feel your thyroid gland if you tried to. TSH is one of our examples that we used in Laboratory 6 before we all got quarantined. And your lab manual is going to be very helpful to review trophic hormones with respect to the hypothalamus pituitary thyroid connection. We studied that pretty in depth in lab last time we were all together. So TSH functions in thyroid stimulation. So it's going to tell the thyroid to produce thyroxine. Okay, so that's the major hormone product from the thyroid gland once TSH stimulates production of thyroxine. And I want to come back and talk a little bit more about thyroxine. We wrote it as a notation for T3, T4 in explanation for the lab, but I want to talk a little bit more about what T3, T4 stands for. Remember, we have to have iodine in the diet in order for the thyroid to be healthy and produce its hormone products. So the combination of T3, T4 in the bloodstream is going to control metabolism. So nearly every cell in your entire body has a receptor for thyroxine. And that's how you get those overall metabolic effects. If we drop down to ACTH, okay, adrenal corticotrophic hormone, ACTH. It's targeting that pyramid-shaped adrenal gland. And we first looked at the adrenals in response to neural stimulation during fight or flight. And now we're going back and looking at the adrenal glands, and we're focusing on a different part of the adrenal glands, the cortex, that upper 2/3, not the middle layer. And I'll show you a little better picture here in just a minute. But the upper cortex, where the hormone is going to be, the ACTH hormone is going to be triggering other hormones, is from that upper layer in the cortex. And that's where a lot of your steroid hormones are coming from. And I want to go through those in a little more detail in just a minute. We come down to the bottom, follicle stimulating hormone, FSH, and LH. Those are gonadotropins, and you can see that they're targeting the ovaries and the testes. So FSH and LH are present in both male and female reproductive systems, and they stimulate their reproductive cells for release. We come over here to growth hormone, or GH. You see bones and muscles and fat or adipose tissue being the targets. Growth hormone typically stimulates the long bones to grow until maturity, until you reach adulthood. And that's when the epiphyseal plates will be closed on the bones and you won't grow any taller. Usually about 18 years of age, you're full grown. And after adulthood, GH, or growth hormone, would help shift metabolism towards maintaining more lean muscle by burning fat. So you wouldn't grow any taller, but you would add lean muscle and reduce sub-Q fat when this hormone's around. And then the sixth hormone, PRL, or prolactin, back up at the top now on the left. Prolactin, just like it sounds, you hear lactation or lactose, lactin, you think milk, okay? So prolactin stimulates the secretion of protein-rich milk in humans from the mammary glands in the breasts. Okay, so I want to talk also about the cells that are secreting these different trophic hormones. So we just went through the 6 different trophic hormones. What about the cells that are secreting the controllers, the trophic hormones that are controlling the release of other hormones? Let's go north from the pituitary across the infundibulum back up to the hypothalamus, which we should be familiar with. This is one of our neural structures in Unit 2. You can refer to figure 6.5 for this diagram in your book. And let's just go through the cells that are actually creating the different hormones that we just listed. So somatotrophs, think of skin and muscle. Somatotrophs are going to release growth hormone, and we saw the growth hormone in just the previous diagram targeting bones, muscles, and fat. Corticotrophs. Does that sound like cortisol or cortisone? Yeah, corticotrophs are going to release the adrenocorticotropic hormone, or ACTH, which targeted that fluffy upper layer of the adrenal glands, which is true glandular tissue, not neural tissue, and you're going to get your steroid hormones from there. Lactotrophs release prolactin, thyrotrophs release the TSH, or thyroid stimulating hormone, and gonadotrophs release the follicle stimulating hormone and luteinizing hormone that we saw in male and female reproduction. Okay, so that's sourcing it from the hypothalamus. And remember, you're going to have a hormonal connection through the infundibulum. So the pituitary is physically connected to the hypothalamus. And then the pituitary talks to the thyroid gland. And this is coming back to the results that we looked at in lab. Why this keeps popping up. Oh, because I said ask me again, sorry. So here we're looking at a microscopic view of the thyroid. You can see it looks very bubbly inside, and the thyroid's responsible for our overall rate of metabolism. Be sure to skip on over to those few assigned pages in chapter 21. Of course, not the whole chapter is assigned to you. This is a nice micrograph in your textbook, figure 21.17. You have a little bit of assigned reading there to give you a little more information on the thyroid. And again, this overlaps with Lab 6 that we did, so make sure and review your lab guide as well. It's going to be very helpful when it comes to the thyroid. So we're looking at the bubbly looking interior of the thyroid gland, and these bubbles are follicles. and that's where thyroxine production occurs. And this is where the iodine has to get mobilized from the bloodstream and from dietary intake into the thyroid gland itself. So we're looking at where the thyroglobulin, which is an amino acid based, sort of a peptide protein based component, um, tyrosine is going to be combined with the iodine, that essential halogen that we need in the diet. Thyroxine, which we kind of clinically refer to as T3, T4, is going to be made up of two closely related compounds. They both contain the iodine. T3 has 3 iodines and T4 has 4 iodines. So the formal name is going to be triiodo or tetraiodothyronine. And those prefixes just tell you how many iodine elements are incorporated into the finished product. So in slide number 20 in your formal lecture notes that have been up on Canvas now for some time, that would be chapter 6 still, you'll see the diagram of the molecules themselves. And because of those aromatic ring structures that you see, let me see if I can get this to pull up. The behavior of the finished product, T3, T4, is going to act like a fat-soluble ligand. When it arrives at the target, it's going to behave like a fat-soluble ligand. And we talked about that in my last video clip. If you need to go back and review water-soluble versus fat-soluble, the receptors are going to be in different places on the target tissue. I think I have the picture here. Yes, those ring-like structures, those aromatic ring-like structures on T3 and T4. You can also see the iodines attached to the ring structures. That is what gives them a hydrophobic behavior in water, is those ring-like structures. And you can see T4 has 4 iodines highlighted in red, and T3 or triiodothyronine has 3 iodines highlighted in red on those ring structures. Okay, the other gland I want to spend a little bit more time on are the adrenals, the adrenal glands. As we finish up with endocrine and make a shift towards muscle, there's a couple of things I want to walk you through with the adrenal glands. Now, these pyramid-shaped adrenal glands sit on top of each kidney. So right and left, very deep in the abdominal cavity, kind of attached towards your back. Actually, the muscles in your back help stabilize the kidneys. And the adrenal glands produce adrenaline. We talked about adrenaline for a little bit. We introduced it in Unit 2 as we discussed the fight or flight response, or the sympathetic nervous response. You get that global whole body response during fight or flight, and adrenaline is going to address every tissue in your body because it's going to be dumped into the bloodstream and get your muscles ready for fight or flight. So let's shift our attention here away from the neural portion, which is this darker middle or medullary layer, and let's look at this upper fluffy layer. This is true glandular tissue, and for Unit 3 discussion, we're going to focus our attention on that upper cortex. Okay, so this is figure, you should be able to see with this diagram, and also using figure 6.9 in your book, which zooms in a little bit more closely. This is the diagram where we first got introduced to the adrenal gland, and then figure 6.9 shows you a microscopic view. As you go down through these layers, the cortex is divided into 3 really important layers, and they're going to kick out all are under steroid classification, but they have very different jobs to do. So they have these distinct zones, and I want to go through those with you as we talk about the true glandular portion of the adrenals. Each zone is going to secrete its own steroid hormone, and I've boxed these hormones in according to which zone kicks out that hormone to kind of help you with your study of structure and function, help you get through this a little bit better. So up at the very top, we see our trophic hormone, ACTH, targeting our adrenals. Now, the adrenals are covered in a capsule, okay, on surgical procedure, or if we were doing an autopsy, we would cut through this sort of connective tissue type of thin epithelial layer that kind of encases the gland. So the capsule is not something we're worried about. We're worried about the zones. And we've got the Latin translation, zona. You see the first one we come to as we cut down from top to bottom, going towards the medullary layer. In the middle would be zona glomerulosa, and then a thicker layer called zona fasciculata, and go down to zona reticularis. Okay, so I've boxed in the important hormones. So we've got structure and function on kind of this combo view using 6.9 in your book. So ACTH, or adrenocorticotrophic hormone, is going to target the adrenals and kick off the production of aldosterone in zona glomerulosa, or glucocorticosteroids from zona fasciculata, and then down in zona reticularis, the sex hormones. So let's maybe talk about each of these hormones just a little bit, and then I'll finish up. Okay, so we're in the upper portion. There's 3 different layers or zones, and they're responsible for 3 totally different hormones. Okay, so in zona glomerulosa, the aldosterone is classified as a mineralocorticosteroid. Minerals. Minerals. Salt, potassium, right? The electrolytes. Okay, so zona glomerulosa is responsible for a class of steroid hormones called mineralocorticosteroids. Primarily, it's going to kick out aldosterone, which you see boxed in here. This is going to help regulate sodium reabsorption and the release or secretion of potassium through your kidneys. Okay, so it's exactly what you were thinking. Minerals, electrolytes. Okay, kidneys are going to be a Unit 4 topic, but we're going to be there before you know it. This process is going to happen in times of low blood pressure or low blood volume. If you have blood loss, this is going to kick in and help keep your pressure up. Zona fasciculata in the middle. Okay, glucocorticosteroids. Glucose. Do you hear the word glucose in there? Primarily, this is going to be cortisol. Okay, the main hormone is cortisol. It's a stress hormone. Okay, cortisol levels rise when you are stressed out. This is going to raise your blood sugar levels by inhibiting glucose uptake, aka insulin resistance, and it's going to stimulate gluconeogenesis. So you're going to be manufacturing glucose from non-sugar sources. You're going to burn fat, you might burn muscle. Okay, now if we go down to our last zone, zona reticularis, before we hit the neural medullary portion at the bottom in the dark brown. We're not worried about that portion right now. We're just doing the cortical layers. Zona reticularis is responsible for kicking out gonadocorticosteroids, okay, the sex hormones, mostly androgens. Okay, androgens. Maybe you've heard the term androgynous in social settings. Androgens are mainly the sex hormones that regulate reproductive function and also give secondary gender characteristics. Okay, this works in both sexes. Why men look like men, why women look more feminine, more refined. We don't have beards. Okay, that kind of thing. Secondary gender characteristics. I'm going to stop here unless you guys need to email me a bunch of questions if things aren't clear from your full set of lecture notes. Don't forget the other assigned glands and their associated hormones that are included in your full set of lecture notes, along with the other valuable information on hormones found in your lab guide from experiment number 6 that we did together just before school closed out. Watch for my next video coming up on muscle, get you guys started on that, and also there'll be a homework 6 coming up really soon. Okay, you guys take care.